Now we will discuss fat splitting enzymes. They are also called as lipases. As you know that the fat molecules, as we earlier discussed, they are all combination of mixture of triglycerides, and one triglyceride consists of a glycerin molecule, and it has been attached with three fatty acids, or it can be one or two fatty acids as well, but normally a triglyceride would have three fatty acids attached to this glycerin molecule. It would make up a triglyceride, and these fatty acids are different chain length, different carbon chain length compounds. The chain length range from 2 to 22. These fatty acids can be saturated, they can be unsaturated. For example, they can have double bond, or they can have more than one double bond, or they can not have any double bond. So this is what we discuss about the chemistry of fatty acids or triglycerides. Similarly, if we look at naturally, most of the fatty acids which are there in nature, they would have around 10 carbon length. That's a normal chain length. So if we have these lipases, they do the reaction that is opposite to what we discussed now. For example, rather than making these fatty acid chains attached to these glycerol molecules, these fat splitting enzymes would be breaking down these structures into initial structures that were there, for example, glycerol and fatty acids. So these are broken down into simpler compound by the action of these enzymes called as lipases or fat splitting enzymes. Lipases would be, as we discussed, the normal fatty acids do not have any flavor, or they do not have any taste. So that's why most of the fats and oil that we consume, their fatty acid composition, as far as fatty acid composition is concerned, there is no particular taste or there is no particular flavor. If there is some particular taste or flavor, that might come from other sources. And it is also true for the food that have already been spoiled or that has been acted upon by these lipases. So if the lipases break down the fats and oil into glycerol or free fatty acids, these compounds would still remain there within that medium, and maybe we cannot assess that degradation or deterioration within the fats and oil, because the change in color or flavor or taste cannot be assessed very easily. But this becomes important because these deteriorative changes, for example, the release of fatty acids, if such cooking oil are used or other heating mediums, there are other cooking mediums are used for heating or deep frying. These free fatty acids are very volatile, and they might catch fire during the deep frying operation. That is sometimes visible for heating such low quality fats and oil when they catch fire during normal deep frying operation. And this would also lead to formation of a lot of other free radicals and deteriorative changes called as rancidity. So as we said, the opposite reaction takes place in case of action of lipase. There is a glycerol molecule acted upon by lipase. There has to be the water present as well, and then we get glycerol molecule and three fatty acids. The water molecule normally is removed when we make up these triglyceride, but when these triglycerides are broken down, water molecule is needed. These short chain fatty acid, however, as I earlier said, that most of the 10 chain carbon fatty acid chains would not have some profound color or the flavor or taste, but some of the short chain fatty acids, they might have some particular taste or aroma profile. For example, this butyric acid, it is a 4 carbon atom. Then we have caproic acid, caprylic acid, capric acid. These are all fatty acids that have got certain odor and flavor. For example, these capric and caprylic acid are more linked with goat milk, and this butyric acid is linked with butter, and this would have a pungent taste that would be very much sensible. It can be sense easily when we consume butter that has been oxidized. So the butter would release these butyric acid when these enzymes take work on these break down these triglyceride molecules. This butyric acid would tell us that the butter has been spoiled. These phospholipases, they are similar enzymes. They would be splitting these fatty acids in a way that they would be splitting these fatty acid into glycerol and fatty acids. And there are also alcohol groups can be removed from these final product. This alcoholic group would be, it is normally attached with this the phosphoric acid. In case of lecithin, that is a typical phospholipid. It would be breaking down these compounds, especially in our food. And these phospholipids, when they are deteriorated, they would be affecting some of the quality parameters of food, especially meat. The meat would lose its juiciness, and the proteins would be they would be tough in nature. So you can easily feel the difference in meat which has been oxidized by the action of lecithin, that would be breaking down into phospholipids. So these would be actually affecting the overall quality of the end product. The product would lose its juiciness. The proteins would be more tougher, and those changes are, they can be felt if there's a this kind of deteriorative process taking place due to the action of lipases. So this was some information about fat splitting enzymes.